Welcome to the DIY Honda Garage channel. This presentation focuses on the Diagnostic Trouble Codes DTC P2A00 and P2A03, which indicate a circuit range or performance problem for the AF air-fuel sensors in a Honda Odyssey manufactured between 2011 and 2017. The AF sensors play a critical role in optimizing fuel economy and lowering emissions by monitoring the air-to-fuel ratio in the engine. Specifically, P2A00 pertains to the rear AF sensor located on bank 1, while P2A03 refers to the front AF sensor situated on bank 2. Proper function of these sensors is essential for engine management and performance. Resolving these codes typically involves ensuring sensor functionality, connectivity issues, and may require part replacement. Understanding the underlying issues can help technicians provide a systematic approach to troubleshooting. DTC P2A00 and DTC P2A03 indicate a malfunction in the AFAC sensors used to gauge the air-to-fuel mixture in the engine. The AFAC sensor is crucial for maintaining optimal engine performance and emission control. Specifically, the rear AFAC sensor, bank 1, sensor 1, is located before the catalytic converter on bank 1 of the engine, while the front AFAC sensor, bank 2, sensor 1, is positioned similarly on bank 2. Both sensors send real-time data to the PCM, powertrain control module, which adjusts the fuel injection accordingly. An issue with these sensors can lead to poor fuel economy, increased emissions, and reduced engine performance. Determining the root cause of the DTCs is vital for restoring the vehicle's functionality. Several possible causes can lead to DTCs P2A00 and P2A03. First, sensor malfunctions can occur due to age, wear, or damage, which may affect their performance. Secondly, wiring issues such as frayed wires or shorts can disrupt the circuit, sending incorrect signals to the PCM. Thirdly, poor connections, including loose terminals at the AF sensors or the PCM itself, could cause intermittent readings. Lastly, environmental factors like exhaust leaks can also influence sensor readings, leading to erroneous circuit performance indications. Identifying these causes through systematic troubleshooting is essential for effective resolution of the error codes. The presence of DTCs P2A00 and P2A03 can lead to a variety of symptoms that affect the vehicle's performance. One of the most immediate symptoms is reduced fuel efficiency, as the engine may not be receiving the correct air-to-fuel ratio. Additionally, drivers may notice an increase in harmful emissions, which not only affects environmental regulations, but also contributes to potential fines during emissions testing. The check engine light will typically illuminate as a warning that something is amiss with the vehicle's system. Further, the engine may display irregularities in power delivery and responsiveness, particularly during acceleration. A comprehensive assessment based on these symptoms is necessary for troubleshooting effectively. The first step in troubleshooting DTCs P2A00 and P2A03 involves turning the ignition switch to the on position. This allows the vehicle's electrical systems to be powered without starting the engine, enabling diagnostics to take place. It is also critically important to record all freeze data during this process. This information includes engine parameters at the moment the DTCs were triggered, providing context for the fault. Reviewing the general troubleshooting information associated with these specific DTCs can provide additional insights and prevention strategies. This groundwork is crucial for accurately addressing the issue, ensuring further tests are grounded in reliable initial data. After documenting the initial data, The next troubleshooting step is to clear the DTC using the HDS, Honda Diagnostic System. Clearing the DTC allows for a fresh start in testing and gives a clear indication of whether the problem persists. Once cleared, start the engine and hold the RPMs at 3000 without load, ensuring it's either in park or neutral. This step is essential as it allows the engine to reach its operating parameters, including the activation of the radiator fan, a necessary component for maintaining optimal engine temperature. This procedure begins the process of recalibrating the sensors and preparing for more detailed diagnostics. The subsequent step is a test drive under defined conditions. Specifically, ensure that the engine coolant temperature is above 158 degrees Fahrenheit, 70 degrees Celsius, to guarantee the engine is properly warmed up. While on the test drive, keep the transmission in drive and maintain a vehicle speed between 25 and 55 miles per hour for at least 5 minutes. This duration allows the PCM to gather relevant data and assess the sensor's performance during regular driving conditions. Following this, transition to driving at a steady speed between 55 and 75 miles per hour for approximately 10 seconds, and then decelerate with the throttle fully closed for 8 seconds. This simulates actual driving scenarios and gives insights into the functionality of the AFF sensors. In the fourth troubleshooting step, monitor the OBD status for DTC P2A00 and/or P2A03 using the HDS. This diagnostic scan tool provides real-time information about various vehicle parameters and the status of the onboard diagnostic system. Check whether the HDS indicates failed, which would signify that the problem has not been resolved and the faults persist. If the status is passed, the system may be functioning correctly at that moment. But further inspection should be conducted for potential intermittent failures or loose connections. Keeping a keen eye on these readings during this step offers valuable insights for determining the next course of action in troubleshooting. If the HDS indicates a failed condition during step 4, it's time to turn the ignition switch to lock 0 to safely perform the next steps. At this point, replace the AFF sensor, sensor 1, corresponding to the detected error code. This replacement is crucial as malfunctioning sensors can severely affect engine performance and emissions. Once the old sensor is replaced, turn the ignition switch back to the on/to position to initialize the vehicle's electronic systems, preparing for further diagnostics. Following this structured approach allows for a methodical resolution of the indicated DTCs and restores the vehicle's operational integrity. The sixth step in troubleshooting involves resetting the PCM using the HDS after the AF sensor has been changed. Resetting the PCM clears the previously stored programming and adapts it to the new sensor specifications. Following the reset, perform the idle learn procedure, which is critical for ensuring that the engine's management system recalibrates to the normal idle parameters with the new sensor. After completing this procedure, it becomes essential to monitor the system's behavior closely to ascertain that the new sensor is functioning properly. This step emphasizes maintaining optimal engine performance and functionality after replacing vital components. Once the AFF sensor has been replaced and the PCM reset, perform another test drive under the same conditions as before. Ensure that the engine coolant temperature is again above 158 degrees Fahrenheit, 70 degrees Celsius, and maintain the vehicle speed as outlined in previous steps. This detailed monitoring of driving conditions is crucial to evaluate the system's response after repairs. As you conclude the test drive, check for any pending or confirmed DTCs using the HDS. This evaluation is pivotal for determining whether the new sensor has resolved the problem or if further investigation is necessary. Each of these steps reinforces the importance of systematic troubleshooting for optimal vehicle performance. After completing all diagnostic and troubleshooting steps, conduct a final verification of the repairs made concerning DTCs P2A00 and P2A03. Begin by checking for any remaining DTC indications using the HDS. Any new errors could signify unresolved issues. Inspect all connections and wiring related to the AFAC sensor and the PCM to confirm that they are secure and free from corrosion or damage. Ensuring that every component is functioning as intended is essential to confirm the success of the repairs made. Documenting these findings serves as a critical final check, reinforcing the overall effectiveness of the troubleshooting process, while ensuring the vehicle is back to optimal running conditions. Preventive maintenance is key to avoiding issues like DTC's P2A00 and P2A03 in the Honda Odyssey. Regular inspections of AF sensors help in identifying wear and tear before it leads to significant performance declines or emissions failures. Cleaning connections periodically ensures that dirt and corrosion do not interfere with electrical signaling between the sensors and the PCM. Monitoring performance trends over time, particularly related to fuel efficiency and engine responsiveness, can provide early warning signs of potential trouble. Implementing a proactive approach can extend the longevity of sensor components and ensure smoother operation for the vehicle, thus minimizing repair needs and maximizing performance. In conclusion, understanding DTC's P2A00 and P2A03 is crucial for effective vehicle diagnostics in the Honda Odyssey from 2011 to 2017. These diagnostic trouble codes are indicators of potential AF sensor problems that influence both performance and emissions. Following a systematic troubleshooting approach allows automotive technicians to efficiently identify and resolve underlying issues, ensuring the vehicle operates at peak efficiency. Additionally, preventive maintenance measures are vital for prolonging the lifespan of these essential components, highlighting the importance of regular checks and proactive care. Collectively, these steps ensure that the vehicle maintains its functionality and meets environmental standards. Please like and subscribe to the channel. See you next time.